Our objective is I can identify the properties of water that are created by hydrogen bonding. Hydrogen bonding, ionic and covalent bonding take place within a compound to form ions or a molecule. There are other forces of attraction that take place between molecules. These are called intermolecular forces. Inter is the prefix for between, like an interstate goes between different states. The intermission is between acts of a play. So IMFs, which is short for intermolecular forces, are usually represented with dotted or a dashed line. Ionic or covalent bonding is usually represented with a solid line. So intermolecular forces are weaker than actual bonds within a compound. So you'll notice that the line that connects the O and the H is a covalent bond. But if we have a dashed line that goes in between the molecules like this, that would represent hydrogen bonding. However, it can't be just anywhere. It has to be between a hydrogen and the oxygen of its neighbor to be a hydrogen bond. So let's look at that a little bit closer. The strongest intermolecular forces are called hydrogen bonds. There's more than one, but this is the only one we're going to focus on. So hydrogen bonds or hydrogen bonding is when the hydrogen of one molecule is attracted to the negative of a neighboring molecule. And this only happens with nitrogen, oxygen, and fluorine, but you only need to worry about water. So here's the hydrogen of one water, and it is attracted to or hydrogen bonding to the oxygen of its neighbor. So you'll notice that all the dashed lines here are hydrogen bonds, which are not as strong or weaker than these actual intramolecular bonds or covalent bonds between the hydrogen and the oxygen. So this is just an attraction between this hydrogen and the neighboring oxygen. So let's label this hydrogen bonding, or these waters that are all around each other. So first of all, this dotted line is the hydrogen bond. Okay, then this one is pointing at the dashed line between the oxygen and the hydrogen. That's going to be a polar covalent bond. Now let's look over here. Which atom is this in gray? That is a hydrogen atom. And look, here's another one in gray. That is the other hydrogen atom. So we have the two hydrogens, and then this red is going to be the oxygen atom. So there's our H2O. Now, what is the charge on the hydrogen? The hydrogen is going to have a partial positive charge because it is less electronegative than the oxygen, which is going to have a partial negative charge. So that squiggly S, which is a lowercase delta, means partial. So, properties of water. Groups of water molecules behave as they do because of the hydrogen bonds that they have. So, water, if you try to boil water, it takes a long time to get the liquid to change into a gas. It takes a lot of energy to break apart the intermolecular forces, and so you're going to have a low vapor pressure. It's going to evaporate slowly, a low vapor pressure. However, everything else about water is high. It has a high surface tension. Like if you have a belly flop in a pool, it's going to hurt because the surface tension is very high for water. Water has a high heat capacity, so it has a high ability to absorb heat from around it. Water has a high boiling point, so it takes a really hot temperature to get water to boil. Again, it takes a high temperature to overcome those hydrogen bonds between the molecules, break them apart so that the water can boil and turn into a gas. And then water has a high heat of vaporization, which is the amount of energy necessary to change from liquid to a vapor at constant pressure. So more about surface tension. Since hydrogen bonds allow water molecules to attract to other water molecules, they like to stick together. To break the hydrogen bonds and lower surface tension, you could add a surfactant like dish soap. So if you were to poke this with a stick that has soap on it, then it would cause the surface tension to break apart. Surface tension is also what allows things like these bugs to walk on water and what keeps the water in this rounded beaded shape. So let's look at an example of surface tension. Here's a penny, and I'm going to keep adding drops to it, and you'll notice that the surface tension holds it in like a bubble shape. So here you can see the surface tension is what causes the water to bubble up, also the cohesive forces, thanks to the hydrogen bonding. And then here's what happens after we add a surfactant. And here's another visual of surface tension due to hydrogen bonding. So more about heat capacity. The high heat capacity of water helps to maintain a moderate climate. Areas near large bodies of water will see a smaller change in temperature. So living near the Gulf or by a large body of water, the water absorbs the heat and keeps the temperature pretty steady. More about boiling point. Because hydrogen bonds allow water molecules to attract to each other, it takes a lot of energy to get water molecules moving fast enough in order to change to a gas. A weird thing about water is most liquids get more dense when they freeze. Ice, however, is less dense than water, so ice floats. Hydrogen bonds form a honeycomb structure in ice that causes it to be less dense than liquid water.